Good morning and welcome to the enclosure. Today is a very exciting day. Last night I energized the Leviton load center, which meant that today I could turn on our Rheem hybrid hot water tank. And so it's got a 30 amp 220 feed, and once you turn it on, it goes through some configuration, and then it's live. And so we're set for 120. We're in heat mode only, which means that it's not going to rely on the elements at all to heat the water. That's the most efficient system, but it takes longer to heat the water. To go between the modes, you basically hit the mode, and this is vacation, so you can set it for as many days as you want. Goes up to, what does it go up to? It goes up to hold, or the last one is 28 days, so hold would be indefinitely. Heat pump mode, high demand mode, which means it's relying on the elements, the resistance elements, or there's off, or there's energy saver mode. Energy saver mode is it'll use the elements when it thinks it needs to meet your demand. We want to stay, we don't obviously have a lot of demand, we're going to stay in heat pump mode only. I'm the only one here during the day, so I'm not going to be using a lot of hot water, basically to wash up and every so often wash some dishes for the lunchtime barbecue. But yeah, it's awesome. I will come back and tell you how long it took to get hot water out of the taps. It does not say, I don't think, it does not say what it does. So we're at 81 degrees already. So this has been on for about 10 minutes. And I know that water coming in is roughly 45 to 50 degrees this time of year, Fahrenheit. And we're now at 81.4 degrees, the upper tank temperature. The lower tank is at 69, and our ambient is 63.5. That's the air in this room, which I don't think is quite accurate. Maybe it's the air inside the unit. Suction temperature 46.9, evaporator temperature 45, so that's the actual heat pump refrigerant, and discharge temperature 94.3, that's what it's giving to the coil that heats up the hot water. So I will come back, so we're at 82.1 right now. I'll come back and let you know how long it takes to get up to 120. And right now it's in pre-warm mode. I guess it sensed that it was a brand new unheated tank. The water was so cold, so it is using the upper element to supplement the heat pump. I guess that's why it is heating up so quickly. Compressor relay is on. The evaporator fan control is on low speed. This has the sound decibels of a fridge that is currently on. So like when the compressor comes on a fridge, this is basically the sound level. It's not something you would want in the main living area where you could hear it, say in bedrooms. It would travel up easily up to the third floor or second floor from the basement if it was in sort of the common area. This is the concrete, call it the concrete bunker underneath the garage, the excavation under the garage, and it's basically concrete on all 6 sides. So I have no fear whatsoever that it's going to transfer into the rest of the house. I'm not sensing any vibration on the floor at all. There's not a vibration transfer to the concrete floor. So that is awesome. Now, currently I'm in an unconditioned dwelling. There is no heating or cooling system in this dwelling. So it is going to be extracting heat from this room to create the heat in the hot water. And that means this room is going to cool over time. And eventually it'll get to the point where it probably can't extract enough heat from this room because it's too cold without having a supplemental heat source. We'll see how long that takes, and I'll report back in future episodes. But it is helpful because it's also a dehumidification system. And right now I have 4 open pits. I'll just turn you around here. I've got 4 open pits for the building science labs that I'm putting in. And they basically go right down to the gravel, and below that is the groundwater. So there's a fair amount of humidity in this room, and so this will help take care of the humidity until I finish the labs and get the concrete tops on them. So thanks for visiting, and we'll see you once this is up to 120 and let you know how it goes. Take care. Hey folks, welcome back. Sorry once again, had some video technicalities. This time I don't remember whether or not I just forgot to tape the second part of the video, or whether or not somehow I've misplaced it. It's been long days, it's been a long week, it's been a long year, it's been a long build. I'm running on empty here. But anyway, I do remember how long things took. I had, I guess, made some notes. So when I left you, we had turned this on at 8 a.m. We had it set for 140 Fahrenheit, and we were going to see how long it took to get up to temperature. Well, at 10:45, the system shut off. It had reached its target temperature of 140, both at the top of the tank and at the bottom of the tank, because it has sensors at both locations. I came back several times during that, 2.75 hours. And what I noticed is immediately on startup, the top element and the heat pump were operating. The top element stayed on until the internal water was somewhere around the mid-90s. And then it shut off and the bottom element turned on again until the bottom of the tank was in the mid-90s. And then both elements shut off, and from that point forward it was on hybrid only. Now I had also mentioned earlier that I wondered whether or not the ambient air temperature reading, 63-ish, was accurate. And it actually was. The basement here has been consistently at around 66 degrees, regardless of the outside temperature. It's been absolutely awesome. So the main basement's at 66 degrees. This room has always been colder. There is no solar activity working on it. Above we have a covered garage. The rest of the basement, there would be solar coming in through the windows, heating up the first floor assembly, that radiating down to the basement. There's none of that here. So it's basically a concrete bunker. Now, what I do have, which is interesting, I've got a couple or 2 or 3 graphics. I have something called watt sensor. It's tied in with the electrical company's smart device that talks to the electrical meter and tells me my consumption. And it's just another level of monitoring that has a little bit more data manipulation available to it. Anyway, these graphics show the startup on the day of August 26th. And as you can see, starting at 8 a.m., there's a huge spike in electricity compared to the day before. And then by about 10:45, that spike goes down and it becomes more of a normal curve. This shows the consumption of the tank while it was on both hybrid and resistive heating. And it shows why I was so scared of resistive heating. This graphic shows a comparison between the heat pump startup day, August 26, and a normal work day on September 1st, where the heat pump is operating and I'm periodically using the hot water. As you can see, the energy use has flattened and there is no discernible spikes. This final graphic compares the energy use over 2 Sundays, one before and one after the heat pump was operating. I picked Sundays as I'm generally not on site working and therefore no electricity is being used for lights, tools, etc. Notice that the power consumed between the 2 days is virtually identical at 8.9 kilowatt hours. Also note that the scale of the graph has changed from a peak of 4.5 kilowatt hours down to 1.2 kilowatt hours when you are looking at the column spikes on the graph. The column spikes in all the graphics represent equipment turning on and off. In the case of Sundays, this would be the drinking water cooler, the groundwater sump, and most prevalent, the pump in the landscape water cistern. This has many cycles daily as I use it on a timed watering for vegetables and plants, and both neighbors use it manually for their plants. Later, once I have the Leviton smart meter hooked up to the load center, I'll be able to identify individual loads and report back. So these demonstrate why I was so upset when I felt that I was only going to have a 100% resistive heating option available for the domestic hot water when my plans for an outdoor heat pump fell through for the domestic. It is extremely expensive to heat water via electricity. And all of you guys out there that do have an electric hot water tank, you really need to consider, I mean, yes, it's environmentally friendly because in BC, I'm talking about BC residents, it's predominantly hydroelectric, so it has a fairly low carbon footprint, but you're just flushing dollars down the drain. And you really need to look at heat pump technology. It can be retrofitted into most dwellings. Most dwellings will have the required room size that is needed to provide the heat, the ambient air temperature that this requires. I'm finding that at the job site I am using more hot water than I anticipated. I do wash my hands a lot during the day as I'm outside working in the dirt or inside. I've got solvent or something on my hands, and now I find that I'm turning it to the hot faucet on and waiting that I don't know, 5-10 seconds for this lovely warmth to come out, and enjoying hot water coming out of the tap after 6 years of working with cold water. I have turned it down to 110, which is the lowest temperature that it can operate at. That's more than enough for my needs. Obviously, I don't have a shower here, so I'm not showering, and that is the most common way of being exposed to Legionnaire's bacteria, if there is Legionnaire's bacteria in the water, because through the process of the water coming out the shower head, it can aerosolize, and that gets into your lungs and creates the issue. Obviously, that's not going to be a problem at this point. When we move in, I will turn the water temp back up. Want to again thank Mark and Rob over at Rheem for making it possible for me to install this equipment on my job site. I had many a night where I was thinking while I couldn't sleep about what my options were for hot water and how I was going to solve this. At one point, I was thinking of excavating down the side of the foundation and somehow putting a penetration through and a double-walled flue so that I could have natural gas because I really didn't want the cost of electrical. And fortunately, this has worked out, and Rheem stepped up and gave me a large contribution to help me make this a reality on this job site. Once again, thanks for watching. If you like what you see, please subscribe and think about giving us a thumbs up. and head over to theEnclosure.ca, and you'll see a beautiful new website that Honeycomb Creative have done for me, and you'll see some additional commentary that I'll have on that subject. Take care and stay safe, stay healthy, and look forward to seeing you again.